Unit 6 looks at weathering, and this subject is split into physical and chemical weathering. Weathering is the process where rocks and artificial structures are worn away and broken down into smaller pieces. And this is due to either physical or chemical processes. This first section is going to look at the physical process of weathering, and the next section, the chemical process. Surprisingly, the main cause of physical weathering is common or garden water falling as rain. But how does rain break down materials?
Rainwater gets in the cracks in a rock. And to show you what happens, I filled this iron flask with water and I'm going to put it in ice. Rainwater gets into the cracks and freezes. The ice expands as it forms, and the force is large enough to split the rock. Eventually, the rock has so many cracks. This has been very well weathered. Easy.
Water is the only substance that does not contract when it freezes and become a solid. So rocks break up by water repeatedly freezing in the cracks and expanding. Eventually, the rock is weakened and pieces break off. This process is called freeze-thaw weathering. The other type of physical weathering is the effect of the sun. In very hot places during the day, rocks warm up and expand, and at night they cool down and contract. Over many years, this causes the rocks to eventually crack and break into smaller pieces. And this physical weathering is called onion skin weathering. So alternate freezing and thawing of water and the contraction and expansion of rocks are both examples of physical weathering. So let's go on to look at chemical weathering. This is a gargoyle of a lion off a building. And as you can see, he's very worn. His ears have broken off and he's lost a few teeth. Now this has happened mainly by chemical weathering. Chemical weathering is different from physical weathering as it isn't a mechanical process. It's carried out by chemicals in the air or dissolved in rainwater. Now all rain is slightly acidic, and when it falls on materials like this, the acid reacts with the stone and wears it away. Let's take a closer look at the reaction.
Here's the acid. I'm putting the acid on the limestone.
This time hydrochloric acid is used and small amounts are dropped onto the rock.
You can see the carbon dioxide bubbling up and the hydrochloric acid reacting to the limestone.
Now this is on a very small scale. In limestone areas of the country over millions of years, rainwater will react with limestone, which eventually carves out cave systems. Although rainwater is naturally acidic due to carbon dioxide in the air, from industry can make it more acidic. This is what we call acid rain. Sulfur dioxide and oxides of nitrogen are produced by burning fuels and are then released into the atmosphere. These acidic gases mixed with water fall as acid rain. This did have an effect not only on rocks and buildings, but also on plants on land and in rivers and lakes. Stricter controls on industry has meant that this pollution is now far less of a problem. Here are the key points you need to know about physical and chemical weathering. Physical weathering is the process where rocks on the surface are broken up. This is either by alternate freezing and thawing of water in the cracks of rocks, or by the continual expansion and contraction of rocks from the effects of the sun. And chemical weathering is the process where materials are worn away by naturally occurring acid dissolved in rainwater. That brings us to the end of this section on weathering. If you weren't sure of anything, why not rewind and go over the key points? It's also a good place to take a break. Remember, it's your choice.